So as we continue in geometry, we're moving into Module 7, which is going to be our quadrilaterals. And to begin that, we're going to talk about the angles of polygons. We want to be able to prove and use the polygon interior angle sum theorem, and then prove and use the polygon exterior angle sum theorem. So we'll go through some examples, but the definition of a diagonal. I'm sure we've all used the reference or the term or understand. We think we understand diagonal, but just understand for geometry, mathematical purposes. A diagonal of a polygon, right here, is a segment that connects any two non-consecutive vertices within the polygon. So they're saying, when I look at this non-consecutive, if I just went to the next consecutive point, that would not be a diagonal. So what they're saying is non-consecutive is going to, right there, I created a diagonal, and if you think about it, I sort of created a little triangle, right? A little triangle right there. When I connected the next diagonal right here, I actually ended up creating possibly two other triangles, right? That's a triangle, and then this is a triangle. Now I'm showing you this is because this is one of those ways we can prove the angle, the polygon interior angle sum theorem is just seeing that as I make these little triangles, we can understand what's going on. Think about what are the interior angles, what are the interior angle measurements of a triangle? We know that the interior angle measurements of a triangle are going to be, I really don't want that one, are going to be 180 degrees. All of my angles added up together are going to equal 180 degrees. So we use that, we build on that. So I can say that if this was a square, things that we know in the past when we've talked about a square or a rectangle, we know the corners are right angles, which is 90 degrees. And that would be 90 degrees. So we have 90 degrees times 4 is actually, right, 90 times 4 should be 360. So 360 degrees is the number of internal angle measurements of a rectangular square. Well, we just said that 180 for a triangle, 360 for a square, but if you think about it, we can actually divide, if we draw a diagonal here from two non-consecutive vertices, I have a triangle over here of 180 degrees, and I have a triangle over here of 180 degrees, and combined, they equal 360 degrees. And that's how we're looking at these things, and we're trying to prove and use the sum of the interior angles. So when I look at this image over here, let me go ahead and clean it up just a little bit. I know that this thing, when I connected my diagonals, I have 180 degrees here for a triangle, 180 degrees here for a triangle, and 180 degrees there for a triangle. So total, this is a 1, 2, 3, 4, 5-sided polygon. And so it's the measure of its internal angles equal 180 times 3, which is 540 degrees. And now we can move on from that. And that's what they're about to show us here. We actually have a formula for that. So in order to calculate the interior angles, we have the sum of the interior angle measurements of an n-sided convex polygon is n minus 2 times 180 degrees. N is the number of sides that we have. That's why it says n-sided. Whatever that number might be. This was 5-sided, 5 sides, so n would be n equals 5. Triangle is 3-sided, so n is equal to 3. And then of course my rectangle or my square, n would equal 4. So that will give us the information we need. So for this one, we have 4 minus 2 times 180 degrees is 2 times 180 degrees, which we just said is 360. The triangle is 3 minus 2 times 180 degrees, which is 1 times 180 degrees, which is 180 degrees, and then my 5-sided object would be 5 minus 2 times 180 degrees is equal to 3 times 180 degrees, which we just said is 540 degrees for the sum of my interior angles. We don't know what each one of these individual angles are, but we know that all of them added up should be 540. Same here. We didn't know what the triangle was. We didn't know what the angles were, but we knew that they added up to 180, and the same thing goes for that 4-sided. So that is using this formula allows me to make those determinations. So here is, it says find the interior angle sum of the polygon. We know that using the formula that we just used right here, 5 minus 2 times 180, the internal angle measurements are going to be equal to 540 degrees. We know that this plus this plus this plus this plus this, all of those angle measurements will add up to 540 degrees. Looking back here, J was equal to 100. And that's what they did here. They took and they substituted in all of those values. Okay, when they combine like terms, and I did it over here, we have 10x plus 170. So this side added up to 10x plus 170 equals 540 degrees. Then we subtracted 170 from both sides. This became 0. 10x equals 370. Divide both sides by 10, and now x is going to be equal to 37. So we found out that x is actually equal to 37. And now when you plug it back in, we know that j was equal to x. I'm guessing, right? Let's see, 42. J we knew was 142. K was equal to 2x, which is 2 times 37, or 74 degrees. L was equal to 3 times 37 plus 14, which is, I hate to do math in public, I'll come back to it. Here we had 3 times 7 plus 14, or 125, so we'll go with 125 degrees. And then again, 2x was 2 times 37, or 74 degrees. And those were all my separate angle measurements, or different angle measurements that I had within that polygon. So with that, looking at, remember my formula here to figure out what all of my internal angle measurements are, n minus 2 times 180. And it wants me to find the measurement of angle E, which is, this is the algebraic symbol, but I need to find the measurement of that. So in doing so, I should say that this is 1, 2, 3, 4, 5, 6-sided object. So n is 6. 6 minus 2 times 180 is going to be 4 times 180, which is going to be equal to 720 degrees. So we know that angle A, B, C, D, E, F should be equal to 720 degrees. So we can do that substitution now. We know what all of those equal. Will equal, and I'm just going to put it here, will equal 720. So adding it up, how many x's do I have? 1x plus 1x is 2x, plus 1 is 3x, 4x, 5x, 6x. So all of my variables add up to 6x, and now my numbers. 7 minus 3 is 4. 4 plus 6 is 10. 10 minus 4 is 6. 6 plus 2 is 8. 8 minus 8 is 0. So it turns out that 6x plus 0 is equal to that, so 6x equals 720. Divide both sides by 6, because I wanted to get x by itself, and x is going to be equal to 120. So x equals 120. So E right here is x plus 6, or 120 plus 6 equals D. 126 degrees. So the math is relatively easy as long as we understand what it's asking us, how to calculate those interior angles and move forward, okay? So with that, applying this interior angle measurement of regular polygons. Penny is building a house using a floor plan that she designed. What is the measure of ABC? I want to know the measurement of this angle right here, ABC. So this would be ABC, the vertex is B, okay? That's what I'm looking for, and I'm just going to shade it in just a little bit. This is what I'm trying to learn right here, that angle measurement. Describe the task in your own words, then list any questions that you may have. Well, let's see, what do we know? If this is a regular polygon, all of these sides are the same, so it's a regular polygon, it's a hexagon. And that tells me then that I should be able to calculate the internal angle measurements in here. And we just did that. We just learned that in the example above, when n is 6, then the internal angles would add up to 720 degrees. I know that all of my sides are congruent, so that means all of my angles are congruent. I don't know what my angle measurements are, but I know that that's that definition of a regular polygon we've used, that all of those angles should be the same measurement, okay? And that how will you approach the task? I can calculate the internal angle measurements, then I determine that each one of these is the same, so it is a variable 6 times, so very similar to that problem we just did. I don't know what the value is, but we'll call it x, 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 x. So I should have something like 6x should be equal to 720, and we just did that, right? Divide by 6, and x is going to be 120, so that angle measurement should be 120 degrees. Okay, sort of duplicating the effort that we just did. Reason forgot those internal angle measurements. We forgot this formula. What we can do is we can look at this and say, okay, how many triangles can I create? Creating my triangle. Let's see, if I connect my non-consecutive vertices, I actually created 1, 2, 3, 4 triangles, and then I know that 180 times 4 is equal to 720 degrees. So if you forget that formula, there is a way to determine it just by using the triangles, okay? So that's some of the things that we can think about. Strategy for solving the problem, write an equation, see previous page. Some of the interior angles of a regular hexagon we said was 720 degrees. So that is sort of what we were looking at. Now, again, if we first move on, in this check, what do we got? Miguel has commissioned a pentagonal koi pond to be built in his backyard. He wants the pond to have a deck of equal width around it. The lengths of the interior deck sides are the same length. Okay, so the lengths of the interior deck sides are the same length, so that means it sounds like it's a regular polygon. And the lengths of the exterior sides are the same. Okay, so that's telling me that the length of the exterior sides are also the same. Measure the angle of the pond. The measure of the angle of the pond formed by 2 sides of the deck is. So 2 sides of the deck, the angle of the pond. We are trying to figure out what in the heck this angle measurement is right there. So again, we can determine use our formula, n minus 2 times 180. That is a 5-sided object, right? A pentagon. So I have 5 minus 2 times 180, which is 3 times 180, which we say is probably 540 degrees. If you couldn't remember that, you can deconstruct, right? I got 1, 1, 2, 3 triangles I could have multiplied by 180. Okay. And then we have, since it's all my sides are the same, it's a regular polygon. So I know that again, all of these angle measurements are the same. So I just simply have to take, I have 6x is equal to 540 degrees, divide both sides by 6. So x is going to be equal to 54 divided by 6, 9, 40 divided by, let me see here. 540 divided by 6 goes in 9 times, 5400. So okay, so anybody catch what I'm doing wrong? How many sides are in my pentagon? 5. I got way ahead of myself, right? So if I back up here, let's do all this right, make a little bit more sense. I knew something was wrong. So, but I just couldn't put my finger on it right away. So 5x, right? Because there's 5 of those angle measurements. Now when I divide by 5, now it makes a lot more sense. You're like, Jackson, where'd that come from? Yeah, we needed 5 sides. So again, x is equal to 5 divided into 540. It's 1, right? 5, 0, bring the 4 down, that's a 0. 0, 4, 0, 108, right? 108. So that would be 40, 0. So 108 degrees is the measurement of that angle. Those two sides form a 108 degree measurement. Now, identify the polygon given the interior angle measurement. Okay. Well, they're saying, hey, they're going to give us the interior angle measurement. Now we need to figure out how many sides the polygon actually has. So again, we are trying to calculate what n is. So it says the measure of the interior angle of a regular polygon is 144 degrees. Find the number of sides of that polygon. So we know that 144 degrees times the number of angle measurements is equal to n minus 2 times 180 degrees, right? That's my formula. So what I have some variables on both sides. I end up needing to do some fast math. So over here, they didn't give me enough room over there. 144 times n, or 144 n equals n minus 2 times 180. I distributed the 180 into my parentheses, order of operations, right? 144n equals 180n minus 360. Subtracted 180n from both sides because I'm trying to get all of my variables on one side. And then have negative 36n is equal to negative 360, dividing both sides by, look at this bad math again. Right here, I divided by negative 36. Negative 36. It turns out that n is equal to 10. So I was able to calculate the number of sides of my pentagon has 10 sides. So n was 10. So there you go. You should probably, at this point in time in your education, be able to know these. You have a triangle, quadrilateral, pentagon, hexagon, maybe heptagon slips through, but you should know what an octagon is. Maybe a nonagon slips through, but you should probably have a decagon. So just think about, make sure you're, advancing and improving on your vocabulary, things that you should know. And I will just say here, measures of doing this check, measure of an interior angle of a polygon is 150 degrees. Find the number of sides. 150, right, is the measure of my interior angles times the number of sides, or number of angles, which is the same as the sides. And then I have n minus 2 times 180. So 150n is equal to 180n minus 360. Subtract that 180n from both sides because I want to combine like terms. I have negative 30n is equal to negative 360. Divide both sides by 30. And then n, the number of sides, is going to be equal to 12. So that one would be a dodecagon, a 12-sided polygon. So there you go. Being able to just walk through and use that formula. Having that formula, understanding it, and with that, let's see, I'm going to show you an easier way to do that too. Exterior angle measurements. This is one of those definitions for us. Polygon, exterior angle measurements. The sum of the exterior angle measurements of a convex polygon, one angle at each vertex, is 360 degrees. All of the exterior angles of a polygon add up to 360 degrees. I don't know what these angle measurements are, but I know that angle 1, 2, 3, 4, 5, and 6 added together equal 360 degrees. If I wanted to prove that, let's see, I could say that I have a triangle. If I have an equilateral triangle, equal angle, this is 60 degrees, this is 60 degrees. Now what they're talking about is my exterior angles would extend out. Remember what exterior angles are, right? I know that this angle should be 120 degrees because it is a linear pair to that interior angle. This is 120 degrees, again, because of that linear pair. And this is 120 degrees because of that linear pair. And that is 120 times 3 is equal to 360 degrees. So that's proving my exterior angles of a polygon are equal to 360. I could do the same thing with a rectangle, and then, it's... All right, so it gave me that, and we know that this is 90 degrees. So all of my interior angles are 90. 90, 90, 90, 90. And then my exterior angles would extend out. And again, linear pair, right? 90, 90, 90, 90. And again, 4 times 90 is equal to 360 degrees. So yeah, this is definitely something that it's a theorem. It's something very easy for us to prove. So with that, looking here, finding the missing values. 1, 2, 3, 4 exterior angles. They should add up and be equal to 360 degrees. So I have 6x plus 9x plus 2x plus 39 equals 360 degrees. Combining like terms. Combine all my x values, got 17. 17x plus 139 equals 360. Subtracting 139 from both sides. And 17x is equal to 221. And then when you solve that, let me see here, x would be equal to, don't have a calculator, 117, let's see, that would be 4, no, that would be 5, bring down the 1, that would be 3, 51, remainder of 0, so x is 13. So there you go, x is 13. Be able to calculate that based on that 360 degrees. And we'll do this check real quick. What do I know? I know that all of my exterior angles, 1, 2, 3, 4, 5, should add up to 360 degrees. Okay, so I went ahead and added my angles up. 2x plus 88 plus x plus 10 plus x plus 2 plus 52 equals 360 degrees. combine like terms, I have 4x plus 152 equals 360. Subtracted 152 to get it over here to isolate my variable. Divided by 4 both sides. X is going to be equal to 52, and we are done. X is 52. Okay. So let's see, what else do we need to do? Finding exterior angle measurements of a polygon. Well, we know the exterior angles, we know all of them add up to 360. So find the measure of each exterior angle of a regular polygon. Well, if a regular polygon means that they have congruent sides. So if I have 12 sides, that means I have 12 angles, right? So 12 times the number of sides equals 360. If I divide by the number of sides that I have, I get the answer, which is, I want to say 30. So there's a 30-sided object, or I'm sorry, 30 degrees. The measure of each exterior angle is 30 degrees. So what they said is, I'm just going to not draw on a scale here, but I have, just continue, just assume that that's my polygon. And they said that the external angle is 30 degrees. So do we know what the internal angle is? I hope so. I hope we know it's 150 degrees, because your exterior and your interior angles could form a straight line. They're a linear pair, they're supplemental, they equal 180 degrees. So that is actually an easier way for me sometimes to find the interior angle measurement. If I know how many sides it is, I could divide that into 360 and come up with my interior or my exterior and know the supplement to that. But, it's just a matter of practice. So the measure of each exterior angle of a regular octagon, hopefully you know at this point in time an octagon has 8 sides. So it would be 8 times n is equal to 360 degrees. Divide both sides by 8, and n is equal to 45 degrees. And that is angles of polygons. We use these moving forward. We've used them in the past. It's just a matter of being able to tie it all together into a larger function of geometry. So we'll move on, but this is going to carry forward. You've been doing it up until now, but now we can say, hey, there's a theorem justifying my actions.